quickly. The average rate of change of a function between 2 points, can anyone dictate it? Please, anyone? The average rate of change of a function between 2 points.
Is that the equation for m?
Yes.
So x1.
It can never start with x. It's a rise.
Sorry,
it's
y1
rise over
y2 minus y1.
Yes, it's rise over 1. We can never start with x. It has to be y, the change in y over the change in x. Okay, good. Now what about the difference quotient? Can anyone give us the formula for the difference quotient? Difference quotient. Anyone, please?
F of x plus h minus f of x over h.
Excellent, thank you very much. And can anyone explain in a couple of words what I like to call note 1 and what I like to call note 2, or call them the way you like, it doesn't matter. What is the note 1 for the
on the numerator? You have to get rid of all numbers that don't include h. And,
exactly. Every term that does not have h must simplify. If it doesn't simplify, I have to go back and start from scratch. Awesome. And final note. What is the second note?
You have to get rid of h on the denominator.
Excellent, that's it. That's all there is to it. Okay, so I just copied this problem from last time. I'm going to recycle this. It's gone. So we want to find the difference quotient for this problem, for this function. So we have the difference quotient. You already gave it to me. F of x plus h minus f of x divided by h. So we plug in x plus h here, and we have negative 2x squared plus 2xh plus h squared. We replace this by x plus h, so we have plus 4x plus 4h and plus 1. And now we have to subtract the function. When I subtract the first term, I get plus 2x squared. When I subtract the second term, I have minus 4x. And when I subtract the last term, I have negative 1. So let's take a moment and say yay or nay. Is this okay? Is this okay? Anyone? Yes? No? Please say something, please.
No, you need to distribute that -2.
Yes, but so far. Is it okay so far?
This is okay so far, yes.
Good. So I already see the negative 4x with the positive 4x and the negative 1 with the positive 1 because I run out of room always. And now, yes, I'll distribute negative 2x squared minus 4xh minus 2h squared plus 4h and plus 2x squared divided by h. And yes, indeed, all terms without h go away. Some terms with h will, depending on the function. That's a bonus. But definitely all terms without h must go away. And now, as we did before, we have to factor out h. So I have no room here. So when we factor out h, or if you want negative h, then eventually the factor will go away. Do not simplify before you factor, please. Please do not simplify before you factor. So now, because I factor a negative h, I have 4x. Because I factor a negative h, I have positive 2h. Because I factor a negative 4h, I have negative 4. And this is the form, with minus in front, and I have 4x plus 2h minus 4. Any questions on this problem? Any questions for me, please? Is this okay?
Yes.
Okay, perfect. So here's the plan, but of course it depends on your questions. I would like to discuss odd and even functions. I would like us to review transformations. I would like us to look at division of polynomials. There are two types. Rational functions. And then we'll go back to word problems, from exponential and log, and also other modeling problems. So that's the plan before we review for the test. I moved the test from the 2nd to the 7th. Okay. Any questions? Is there anything that you would like me to continue with? Anything that you have questions on? Anything that you encountered, you need help with? Anything before we continue with odd even functions? Anyone, please? Okay, so in that case, let's talk about odd and even functions. Odd and even functions have nothing to do with odd numbers and even numbers. It's just a name. You may want to say it's an odd name. Okay, I agree. So odd functions, even functions. Now, what does this mean? What is an odd function? An odd function is a function that is symmetric with respect to the origin. So here's an example of an odd function. Very well known, y equals x cubed. So this is an odd function, and it is symmetric with respect to the origin. What does that mean? Well, if I connect a point anywhere in the first quadrant with a line segment going through the origin and continue till it hits the function again, this piece will equal this piece. This portion will equal this portion. If you remember the rule, so if this is x and this is f of x, then this is negative x and this is f of negative x. So for this point that has coordinates x, f of x, it corresponds this point that has coordinates negative x and of course f of negative x. And there is a very important relationship between this number and this number. They're opposites. If this is 5, this has to be negative 5. If this is 10, this has to be negative 10. So the algebraic relationship is that negative, or I could say f of x is the opposite of this. So there are different ways of writing this. So here's one way. F of negative x is the opposite of f of x. This number is the opposite of this number. F of negative x is the opposite of this number. If this is 5, f of negative x will be negative 5. Similarly, we have a situation in which functions are even. Has nothing to do with 2, 4, 6, 8. So this function is even because it's symmetric with respect to the y-axis. This point here is x, f of x. This point here is negative x, and of course f of negative x. So they are equal in this case. Here they are opposites, but here they're equal. So here we write that f of negative x equals f of x. No change. Here, notice that I started with the same thing. Here it's the same. Here's the opposite. Very easy to remember. For even functions, so they are symmetric with respect to, lazy people write WRT, with respect to the y-axis. Here is symmetric with respect to the origin. Now, the question is why? Who cares? Why do I care if a function is odd or even? What's a big deal here? It's not. It's not a real big deal. But why is it important though? Can I graph a function without knowing that it's odd or even? Yes. But it makes my life easier if I do know whether it's odd or even. And the chances are that I may not make mistakes. So why is it important? It's because it helps us graph a function quickly. It helps us understand the pattern better. But it's not a huge or such a big deal if I don't know whether a function is symmetric or not. It's nice if I do, but it's not a life and death situation. So why? It's good to know. Okay? And it will be easier to graph. It's a property. Not all functions are odd or even. No, no, no. This is a property of a function. If a function is odd, I will make sure that it's symmetric with, when I graph it, it's symmetric with respect to the origin. If I know that the function is even, it's a property of this function. It's an awesome property. What I graph here, I graph here. First quadrant, it appears in the second quadrant, or the fourth and the third. Here, what I graph in the first, I have to graph in the third, or vice versa. What I graph in the second quadrant, I have to have a copy in the fourth quadrant. So it's nice to know about the property, odd or even. Now, if I'm given functions, and now let's look at the handout and finish that handout, if I can find it. I thought I had it right here in front of me. I lied. No, I have it. I didn't lie. So the handout is the one with difference quotient. So we're going to select in a minute. We're given all sorts of functions and we're asked, are they odd or even? They may or may not. So I'm going to choose or you choose. Let me open the handout for you. In case you don't have it in front of you, let's open it and let's choose. Let's choose a couple and leave another one or two, maybe three for the review. But let's illustrate. I'm almost there. I got it, I opened it, and here you are. I'm sharing my screen. So this was done with all these functions, and now we are looking at odd and even. So we're asking us, is this odd? Is this even? What is it? What is the procedure? How do I show? So let's choose a function. Anyone would like to choose? If not, I will. I will choose 46. Is anyone with me? Did I lose everybody? No one is with me? Anyone?
I'm here.
Okay. Thank you. Good. So the question is asking us, is this function odd, even, or none of the above? No matter what I do, I will find f of negative x. That's my target. Because if the function is odd, I have to calculate f of negative x. If the function is even, I have to calculate f of negative x. So that's my starting point. So h of negative x. The top gets replaced by negative x. X gets replaced by negative x, but when I square it, nothing changes, because negative x squared is still x squared. I will put a negative in front, and I get this. So I determined the function evaluated for negative x. So now I have 3 questions for myself. Let me move on to the next page. So here's what I'm asking myself. First question, does this equal age of x? Does this equal the opposite of age of x? Or none of the above? I can have yes only for one of those 3. There is no function that is odd and even at the same time except y equals 0. Only the x-axis is a function that is odd and even at the same time. There is no other function that is odd and even at the same time. And who cares about y equals 0? Nobody. It's the only function that is symmetric with respect to the origin and also symmetric with respect to the y-axis. But it's a useless function. So I determined age of negative x, and I have to have yes for one of these 3 and no for the other 2. Can anyone predict or give us an idea?
Would it be the
Yes.
would it be odd?
Yes. So this is a no, this is a no, and this is a yes. Thank you so much, Kevin. So why is it the case? Because this is age of x, and it turns out that age of negative x is negative or the opposite of the original function. Exactly what I see here. So age of negative x equals negative age of x. Age of negative x equals the opposite of age of x. Therefore, the function is symmetric with respect to the origin. And it's an odd function. So we will write odd. Excellent. Any questions on this problem? Any questions on this problem?
Actually, yeah.
Go ahead,
When you were distributing the negative sign, I got confused as to why you didn't make it +1. Because, I mean, you explained it, but for some reason I zoned out. My bad.
So repeat the question.
So when you started with h of negative x, right, and you distributed, or you made it negative x in the numerator, why didn't you make it negative x squared in the denominator? And then also put make the -1 +1 instead?
Is this clear about the -1?
Oh, I'm only just changing the x's,
But
in essence?
the pattern, let's read the pattern. Age of whatever is whatever over whatever squared minus 1.
Oh, okay.
I can't change the pattern. The pattern has to be read. You don't have to read it out loud. I will. F of whatever you want is whatever you want divided by whatever you want squared minus 1. Is that part clear?
Yeah.
Perfect. That's all I did. Age of whatever is whatever over whatever squared minus 1. Anything that I squared is positive. Is that better?
Yeah. Thank you.
Now, all the other steps are clear now or not yet?
Everything else made sense. I was just confused on that.
Okay, good. Excellent. Other questions from me, please? Other questions? Okay, let's choose another. Please don't be shy. We need to discuss these things. It's so much easier to discuss them in class. So don't say anything. I have to switch.